Hello, everyone. This is your Sir Arnie.
And this is your Sir Kevin.
And of course, your Sir Neil, and we are your basic calculus teachers. Now, reminder for everyone that we are sorry to inform you guys that we cannot turn on our cameras the entire time because our bandwidth does not permit. Now, let's start with a prayer. Anyone from our class managers lead the prayers? All right, thank you, Mr. Gabon. In the name of the Father, of the Son, of the Holy Spirit. Amen. Amen. All right. Thank you, Mr. Gabon. Hello. Hi. Good day, class. Am I audible? All right. Thank you, Mr. Fernandez, for your quick response. Now let's start or let's move on to the checking of the attendance. So anyone or someone from our class managers to check the attendance of his or her classmates. Okay, thank you, Mr. Cabajo. Please chat me on the messenger that whose students kanang kung kinsa ang mga students nga ni attend sa karon nga meeting o kinsa pud ang wala ni attend sa meeting. Okay? Okay. Now, before we discuss the topic class, are you ready for our activity today? So ready ba mo nga mo energize at ang brain cells? Okay. I'm sure you are. Now, okay, wait for a while. Here. Now, have any of you tried to ride a roller coaster or naba sa inyo nga nakasulay o sakay sa roller coaster labi na sa katong Anju World, di ba? Na may mga rides sa Anju World. So, kinsa man class, kinsa may nakasuway o sakay sa roller coaster, okay? Natay na po ka students nga nakasuway. So, how about the others? How about sa katong 17 nga students? Okay, I think wala, no? So, sa katong wala pa nakasakay, okay? Sa katong 17 ka students nga wala nakasakay or wa nakasuway yung sakay sa roller coaster, please imagine you're riding a roller coaster, okay? Okay. Now, for the first picture, what do you think if we were going uphill? So, kung sa may inyong paminaw class, kung padung ta sa babaw or padung ta pasaka, is it positive, negative, or a zero? All right. Thank you, Miss Nipange. It's positive. Nganong positive man Nipange? Nganong positive man? Okay, kay tungod nga pa-upward man siya, no? Pa-upward. Okay. How about for the second picture? Going downhill. What do you think if we were going downhill? Is it positive, negative, or a zero? Okay, it's negative. Okay, nga naman negative daw B, Miss Jaime? Nga naman? Okay, thank you. Kay tungod nga pa, downward man, no? Pa-downward ang iyahang um, padulngan. Okay. Now, for the third picture, at the peak. So what do you think if we were going at the peak? Is it positive, negative, or zero? Okay, negative, sir. Okay, all right, all right. Nganong zero man? Nganong zero daw, be? Okay, kay tungod nga flat or ang ato ang kaugalingon kay naman sa at rest. Okay? Now, be, let's give a virtual applause for those students can participate. Okay, very good. Now, based on these three pictures class, sa positive, negative, o ni zero, what words comes in your mind kung nga ma-relate, no? Nga ma-relate sa tuang next nga topic or sa tuang discussion karong adlaw? Okay, nakakita ko na nag-answer og line. Nakakita po ko na nag-answer og positive, negative o zero. Pwede po siya. Okay, napod ko nakitaan nga curve. Okay, lantaw na to class, no? Let's see nga kanang mga words nga inyong gi-chat sa atong chat box nga ma-relate pa siya sa tuang discussion karon. Now, our topic for today is all about derivatives as the slope of the tangent line. Now, let me share to you our learning objectives. So at the end of the lessons, or at the end of the lesson rather, you learners must be able to, number one, illustrate the tangent line to the graph of a function at a given point. Number two, apply the definition of the derivative of a function at a given number. And number three, of course, relate the derivative of a function to the slope of the tangent line. Now, let's talk about the tangent line. So based on the definition class no, that a tangent line is a line which locally touches a curve at exactly one point. So as you can see on the picture class, we have two lines, okay? Okay. Now, the first one is we have curve line. Asa man ato ang curve line, be? Wait, let me use the laser. Okay, here. So, muna ito ang curve line class, okay? This is our curve line. And the second one, or the second line is the slant line or kanang horizontal, okay? Horizontal slash slant line, okay? So sa kaninga nga line class, no? Kani nga dapita kay gitawag na siya og tangent line. Nganuman, kay tungod nga kani nga line kay ni touch man siya sa atoang curve line. Okay. So any questions or clarifications before we proceed to the next slide about sa kani nga tangent line class? Nakasabot ra ba? Okay, please send or please chat on the chat box nga mo send mo og thumbs up serves as your nakasabot ba mo sa ko ang discussion karon. Okay, very good. Okay, Sir Narte, it's your floor to discuss this slide.
Okay, thank you, Sir Neil.
Okay, thank
Hello,
you.
students, once again. Now, you already know what is tangent line is, right? So which the line touches at exactly one point at a curve. So moreover, the precise definitions of a tangent line rely in the notion of a secant line. So a secant line is the line touches 2 points at a curve. So let's say be the graph of a continuous function y equals f of x, and let p be a point on C. So first, a secant line to y equals f of x through p is any line connecting p and another point q on C. In the figure at the left, the line PQ is a secant line of y equals f of x through p. So first, let's see be our curve. So as you can see, there is a point P and point Q. So when we connect the 2 points, we could create a secant lines PQ. So next, we choose another point Q1 in between P and Q. Then connect the 2 points P and Q1 to construct a secant line PQ1. So Q approaches P from the left. So we need to put another point on our curve, which is the point Q1. So in between point P and point Q. When we connect the 2 points, which is the point P and Q1, we can create another secant lines P, Q1. Then choose another point Q2 in between P and Q1 and construct the second line PQ2 as shown on the figure at the left. So another point is in between P and Q1. So that is our point Q2. When we connect the 2 points of PQ and P and Q2 rather, we could create another secant lines. Next slide, please. So if the sequence of the secant lines to the graph of y equals f of x through p approaches one limiting position in consideration of points q to the left and from the right of p, then we define this line to be the tangent line to y equals f of x at p. So as shown at the figure at the left. So as q approaches p from the left, then we have many points, right? So we have many secant lines. So the tangent line is the limiting position of all secant lines. But as you can see in the our tangent line, it only touches at exactly one point, which is the point P. To summarize the definitions, we have let C be the graph of a continuous function, y equals f of x, and let P be a point on C. So first, we let our curve know y equals f of x to C, and we have our point P. And then a second line to y equals f of x through P is any line connecting P and another point Q on C. So we have our point Q no, on the opposite side of our point P. So when we connect the 2 points, we can create a second line. Next is the tangent line to y equals f of x at P is the limiting position of all secant lines PQ as Q approaches P. So as you, as you can see in the figure, so Q approaches P from the left. So we have many secant lines, but there is one line that only touches at exactly one point on our curve, which is the point P. So next slide, please. So now is the equation of the tangent line at a point on a curve. Given a function y equals f of x, how do we find the equation of the tangent line at point P of x naught? So x naught or x sub 0, comma y naught or y sub 0. Consider the graph of a function y equals f of x, whose graph is given below, and let P of x naught, comma y naught be a point on the graph. Our objective is to find the equation of the tangent line. Again, our objective is to find the equation of the tangent line to the graph at the point P of x naught, comma y naught as shown below. So our point P of x naught, comma y naught, this is our point of tangency. So diri mo agi ang ato ang or mo touch ang ato ang tangent line. Next slide, please. So observe the letting Q approaches P is equivalent to the letting X approaches X naught. So as you can see, as Q approaches P from the left, so it's same or equivalent to X approaches X naught. Since the tangent line is the limiting position of the secant lines as Q approaches P, it follows that the slope of the tangent line at the point P is the limit of the slopes of the secant lines PQ as X approaches X naught. So in symbols, the slope of a tangent line is equal to the limit y minus y naught over x minus x naught as x approaches x naught. So remember, this is our slope formula. In another book, their formula is the limit f of x minus f of x naught over x minus x naught as x approaches x naught. So, pwede rin nyo siya gamiton either of this formula. Next slide, please. It's your turn,
Okay, thank you, Sir
Mr.
Kevin. Now, here are our formula class for the slope of the tangent line. So we have two formulas, so it's still the same. So the first one is m is equal to limit y minus y sub 0 or y naught divided by x minus x sub 0 or x naught, where x approaches to x sub 0. For the second one is m is equal to limit um, f of x minus f of x sub 0 divided by the x minus x sub 0, where x approaches to x sub 0. Now, okay, let's proceed to the next slide, class. Now, slope. So, the slope of a line is a measure of its steepness. Mathematically, slope is calculated as rise over run. So, always remember, class, that the slope is rise over the run. Change in y divided by change in x. Okay, let's have an example number 1. So find the slope of a tangent line to the curve y is equal to x squared plus x is equal to 2. So here are our given class, no? So for x sub 0 is 2, then y is equal to x squared, or f of x is equal to x squared, still the same. Okay, kung makasugat mo og f of x class, y gyapon na siya, no? Parehas na sila. So this 2, okay, is the equation of a tangent line. Then the unknown is our y sub 0. So let's find, okay class, let's find the value of our y sub 0. So unsaon man sir? So man nato pagpangita sir. So here, y sub 0 is equal to x squared. So ang kaning x squared class, no, gikan ni sa tuang kani nga y nga value, which is our x squared. Then next is, since wa ta kay baw or wa pa ta kay baw yun, no, sa pila ang atong value sa atong x, so ato siya gibutang og 2 kay ngano man, nganong nabot man siya og 2 sir? Ang kaning 2 class kay gikan ni sa tuang kaning x sub 0, which is 2. Okay? Now 2 squared or 2 times 2 is equal to 4. So meaning that the value of our y sub 0 is 4. Okay. Now since we have the sa tawag ana class, 3 terms nga na given, so atong buhaton kay ato na siyang i-substitute gamit ang katong slope of a tangent line nga formula, which is the m is equal to limit y minus y sub 0 divided by x minus x sub 0, where x approaches to x sub 0. Okay. Now here, ato na siyang gi-substitute. M is equal to limit x squared minus 4 divided by x minus 2, where x approaches to 2. So sa kaning kuan class, no, sa atong numerator naman tay x squared minus 4, so atong buhaton ana class kay ato siyang ibungkag or ato siyang i-factor out. So nahimo na siyang x minus 2, x plus 2 divided by or over x minus 2. So since class, no, na may parehas nga terms or value, okay, sa atong numerator o denominator, which is the x minus 2, so ato siyang i-cancel class. Okay? Atong i-cancel ang x minus 2 sa atong numerator, ato po i-cancel sa ang denominator nga x minus 2. So ang nahibilin kay x plus 2, or m is equal to limit x plus 2, where x approaches to 2. Next is ang kaning kuan class, ang kaning nga x nga variable na to diri class, diri nga dapita, ato na siyang butngan og 2 kay tungod sa kani nga given nga information nga which is the x approaches to 2. So mahimo na siyang 2 plus 2. Okay? So 2 plus 2 is equal to 4. Okay. All right. Now it's here for Sir Arnie to discuss this slide.
Okay, thank you, Sir Neil. So, hello class, are you still there? Okay, very good. So now let's proceed to our example number 2. And it says here to find the slope of a tangent line to the curve f of x is equal to the square root of x at x is equal to 4. So always remember, the problem tells us to find for the slope. And in order to do that, we need to identify first the given. So what are the givens? First, we have x sub 0, which is equal to 4, and y is equal to square root of x, which is the function of the curve or the equation of the curve, and then y sub 0, which is unknown. So class, we need to find for the y sub 0 first in order for us to solve for the slope of the tangent line. So next, Sir Neil. Next, transition or some animation.
Hello, Sir Neil.
Sir Neil, are you still there? Okay, so in order for us to solve for the y sub 0, we need to use the equation of the curve, which is y is equal to the square root of x, and then substitute the value of our x sub 0. So therefore, we obtain the value of our y sub 0, which is equal to 2. So now, we already have the important information or given values that we need to inject in our formula of our slope. And always remember, the slope or the formula of our slope is m is equal to the limit of y minus y sub 0 over x minus x sub 0 as x approaches to x sub 0. So here, our y, so to substitute everything, no, from our given, so our y here in the numerator part is the square root of x minus the y sub 0, which is 2, over x minus 4, which is the value of our x sub 0. And then we need to multiply it by the conjugate of the numerator. Why? Nga naman, because we cannot directly what do you call this one? We cannot directly substitute the value of x in the given function, because if we do so, it will make our denominator 0, and it will make the function becomes undefined. So that's why we need to multiply it by its conjugate. So the conjugate of the numerator is the square root of x plus 2 over the square root of x plus 2. And then multiply using the FOIL method. So first, let's operate first the numerator part. So obtaining the square root of x squared plus 2 square root of x squared minus 2 square root of x squared minus 4 over x minus 4 times the square root of x plus 2. Okay, so in the numerator part, x minus 4 na lang ang habilin, because the positive 2 square root of x squared and negative 2 square root of x squared can be cancelled, because they are obviously having the same opposite signs. So, and then for the square root of our x squared, of course, to simplify that one, it will arrive to x. So that's why we have x minus 4 in the numerator part. And then over x minus 4 times the square root of x plus 2. And as what we can observe here, x minus 4 can be cancelled. So in the numerator part, only one left, and then the numerator part, we have the quantity of the square root of x plus 2. So this is the final expression that we have. So 1 over the quantity of the square root of x plus 2. So what we are going to do next is to substitute the value of our x, which is 4. So next, so by substituting, we have this one here, 1 over the square root of 4 plus 2. And then to simplify that one, we obtain our m, or the slope, which is equal to 1/4. Okay. So now let's proceed to practice test 1. So this is for you to examine yourself if you have really understood what I have discussed earlier. So we have here, find the slope of a tangent line to the curve f of x is equal to 4 minus x squared at x is equal to 1. Okay, so you only have 5 minutes to answer this one. Okay, so time is up. And please show your answers. Okay, so a lot of you got the correct answer. So this is actually the process or the solution of the practice test one. Okay, congratulations everyone. So now let's proceed with example number 3. So find the slope of a tangent line to the curve y is equal to 3x squared minus 12x plus 1 at the point 2, negative 11. So we already have the given here, x sub 0 is equal to 2, and y is equal to 3x squared minus 12x plus 1, which is the equation of the curve. And then y sub 0 is already given since the point of the tangent C is already given. So y sub 0 is our negative 11. So no need to find for the or to solve for the y sub 0. So solutions, again, the formula of our slope is m is equal to the limit of uh, y sub y minus y sub 0 over x minus sub 0 as x approaches to x sub 0. So by substituting all the necessary informations, so we have here m is equal to the limit of 3x squared minus 12x plus 1 minus negative 11 over x minus 2. So simplify. So we have here 3x squared minus 12x plus 12 over x minus 2. And then, okay, so find the common factor of the equation or of the function. And then we have here 3 times x squared minus 4x plus 4 over x minus 2. And then factor out x squared minus 4x plus 4. So we obtain 3 times x minus 2 times x minus 2 over x minus 2. And then cancel out x minus 2. So we have here 3 times x minus 2. And this is, yeah, the final expression that we have. And then we are going to inject or substitute the value of our x, which is 2. And we will obtain, okay, so 2 minus 2 is 0, obviously. So therefore, and then 0 times 3 is 0. So obviously, our slope here is 0. Okay, so that's it. So now let's proceed with our practice test 2. So you have to find the slope of a tangent line to the curve f of x is equal to 3 over x at the point 3, 1. Okay, so you only have 5 minutes to answer that one. Okay. Okay, so time is up. Okay, please chat your answers. Okay, a lot of you got the correct answer. So this is actually the solution. Okay, so the m is equal to negative 1/3. Okay, Sir Kevin, please take the floor for you to discuss this slide. Sir Kevin, are you still there?
Oh, sorry. Wala na ako na unmute. Okay, so let's move on to the formal definition of derivative. Definition of the derivative. Let f be a function defined on an open interval. I is a subset of real numbers. And let x not be an element of interval. The derivative of f at x naught is defined to be f prime of x naught is equal to the limit f of x minus f of x naught over x minus x naught as x approaches x naught. So same formula with the slope of the slope. So that is the derivative of f at x naught is the slope. Please niya kog balik, Sir Neil. All right, so that is the derivative of f at x naught is the slope of the tangent line at x naught, comma f of x naught if it exists. So notations, if y equals f of x, the derivative of f is commonly denoted by, so these 5 denotations are simply, obviously, denotations in finding the derivative. So f prime of x, derivative of f of x, d over dx f of x, d over dy of y, d over dx of y, and dy over dx. Next slide, please. So for example number 1, so compute f prime of 1 of the function. So f of x equals 2x over x plus 1. Then we have, so the formula is f prime of x naught equals the limit f of x minus f of x naught over x minus x naught as x approaches x naught. So we simply substitute the given, no, the f prime of 1. So then we have f prime equals limit f of x minus f of 1 over x minus 1. And then substitute the given values. So limit, so our f of x is the given function, which is 2x over x plus 1 minus 1 over x minus 1. So the next thing we do is to multiply numerator and denominator by x plus 1. X plus 1 is the conjugate of the denominator x minus 1. So we multiply both numerator and denominator by x plus 1 over x plus 1. Then we have limit 2x minus x plus 1 over x minus 1 times x plus 1. So we combine like terms in the numerator part. Then we have limit x minus 1 because 2x minus x is positive x, and then negative times positive 1 is negative 1. So over x minus 1 times x plus 1. And then we have f prime equals limit 1 over x plus 1. In this part, this is our final expression. So we can substitute the value of our x, which is positive 1. So 1 over 1 plus 1. So obviously it's positive 2. Then our derivative is 1/2. So it simply means the derivative of the function 2x over x plus 1 at x equals 1 is positive 1/2. So do you have any question or clarification about this example? Okay, Nan, so let's proceed to your practice test number 3. So find the derivative of f of x equals square root of x at x equals 1. So same process. So you have 5 minutes to solve or to find the derivative of the given function at x equals 1. Time is up. So most of you got the correct answer. So the derivative of f of x equals square root of x at x equals 1 is positive 1/2.
All right, now let's have the generalization. Now I will be asking 2 questions in order for you to test the understanding of your class. So number 1, how can we say that a curve has a tangent line? Okay, very good, Samonte. How about how important are derivatives in our daily life? Okay, thank you. Now, that's all for today, and I think that everybody understood the topic. So let's give a virtual applause to everybody. Okay, that's all for today. Hearing none, class dismissed.